Hi everyone, thanks for watching laurieWIRED, and today we're going to be working on the first part of a multi-part series where we're going to be analyzing an Android banking Trojan. So a Trojan in malware is just an application that is masquerading as another application or pretending to be a different application. Usually they're legitimate applications, and the banking family is very common among Android malware. Basically, this family is dedicated to trying to steal a user's banking credentials, either by trying to look at all of the different sensitive data that's on the device, or by fooling the user into entering their credentials or sensitive data and then exfiltrating that data to the attacker. So go into JADX. And I've already downloaded this APK. So I'm just going to drag and drop. And first thing, I want to take a look at the Android manifest so I can kind of get an idea of what the entry points are for this application. So I'll open that here. And it looks like it's got a few interesting permissions that we're taking a look at, such as calling the phone, receiving SMS messages, reading and sending SMS messages as well. Now, this is not enough to conclude that this APK is indeed malicious, but it is a good indicator of where to start and what it could potentially be doing. First things first, I want to check and see if this has an application subclass. So application subclasses are commonly abused for packing since they are actually instantiated first. So that code is going to run first. I will go over to my application tag and check and see if we have Android:name, and that will define a class that will be instantiated first if it exists. I will go right, check and see if we have that. Doesn't look like we have one, so no application subclass in this APK. That means our main activity should be the code that runs first when the user starts interacting with this app and actually clicks on the app icon. So Control F to open our search, and let's look for main. And this is going to be our main activity. So this is the first UI component that the user interacts with when they open up this app. And this defines our class right here. And let's find it on disk. We can go to com bth goq, open that up, and we have dog, and this looks like our class right here. Okay, so we have some instance variables right here, and then our onCreate method is going to be running first as soon as this activity is started. And just right off the bat, this looks kind of obfuscated. If you notice, a lot of our variable, method, and class names are named to junk or just single letters. Malware authors do this all the time to try and confuse you so that you can't actually get the variable names that they used when they created this application to give you any clue as to the behavior of it. So they'll obfuscate it by changing all of those method names. And there are a lot of free tools online that will just go ahead and do this for you as a developer. So what we need to do here is we'll need to go into each one of these, analyze the behavior, and then rename those ourselves. But I'm going to go back to the Android manifest and just get a couple more clues from this application. This was our main. I'll be coming back to this shortly. I just want to start, let's go back to the top and look and see if there's anything interesting going on here. All right, so let's first check and see if any classes are defined inside the Android manifest that I can't find in my package explorer on the left-hand side, since this will indicate that this is a packed application. So let's see, com bth goq. That looks good. We have our L right here. Then our class name is defined. Keep going. Let's look at this receiver. God. Let's look for DJMS. Yes, there's our class definition right there. Here is another activity. And remember, the activities are going to be the UI components, and receivers are going to be listening for a particular event in the background, and that's when that code will be called. So this activity is not defined on disk. So I go to com, bth, goq, etc. And then I'm looking for x, y, r, and b, but I actually can't find this class defined. So I'm guessing that this is going to be a very strong class of interest, and it's going to be dynamically loaded at runtime when the application is running. So we're definitely going to want to take a look at this. I'm going to guess that there's going to be a class loader here that will load this and then call particular methods from this class. Okay, so that's interesting. Looks like we have potentially another one. I'm also not seeing the definition for this here. And this looks very interesting since it's trying to listen for WhatsApp push delivery. And just for some background, just in case you were not aware, Android works as kind of a publish-subscribe type of methodology. So if an event occurs on the device, such as sending a text message or something like that, or the device rebooting, the Android operating system will actually send out an event or broadcast an event to all applications that are running on that device. And these intent filters let an application subscribe and listen for those particular events and have that code run as soon as that event of interest occurs. And it looks like we've got a lot of these right here. This one, for example, is listening for if the boot is completed, so if your device reboots, also if the device receives an SMS message, and many other different things over here. Okay. And one more thing to note is that I'm seeing the priority set for this. The priority can be set in an intent filter. The highest priority that a user application can go is 999, since the system priority is 1000. So it looks like they're raising the priority on this, so they'll get priority for all of these events and actions that are occurring. Okay, so I think we've got a pretty good idea of the manifest now and just overall what's going on. So I kind of want to start diving into the code. So for my plan of action here, I'm going to do a little bit of analysis in the first classes that I found defined on disk. And then I think we'll probably try and figure out how additional code is being loaded. And then we'll try to unpack this application afterwards. Let me go back to my main activity. Let's find it again. And here we go. And let's just start diving in and see what interesting stuff we find while we're taking a look at this. And during this analysis process, I'm going to just start renaming classes, methods, and variables to try and bring a little bit of clarity as to the functionality of them so that it's not looking at this, which just looks like a bunch of junk to me, so I can figure out what it's doing. So let's just start from the top. First, we'll take a look at our instance variables. And this is looking for a new class and storing that instance of the class into this variable A. So let's double click here, and that's the class that it's referencing. B.A. And we'll just rename this class. You can press the N key to rename a class. I'm going to start it with malware so I know which classes and variable names are my own versus the ones given by JADX or by the developer. And I'll just call this class A. So then we'll go back. So that's a little bit clearer to read. You can see that we have malware class A being stored into this. I'll name this variable malware class. A, and my naming scheme is going to be lowercase for variable names and uppercase for class names. And keep going down. We rename this class. And you kind of get the idea here. It's a slow process, but it is effective. Oh, this is an interesting class. This looks like has a bunch of strings that are encoded, as well as a few different methods here devoted to decoding these strings. Initially, I noticed that these look base 64 encoded, so what you can do is you can see if they're only base 64 encoded, either by reading the code, or you can throw these into CyberChef and try and base 64 decode these. So I'll include the link to CyberChef as well in the comment section of this video. So all you need to do is paste that into here, do from base 64, and it still looks like this is junk, so maybe this is extra encoded or encrypted, so that didn't work, but sometimes it does if it's only base 64 encoded, or you can try a bunch of different encoding options, maybe it's XOR or something or like that. So I'll go back to JADX, and this looks like our decoding function. So let me go to the definition here, and it looks like, yes, this is base 64 encoded data, but they're also doing something else. So I'm gonna call this, let me see if I renamed this class first. I will actually name this something else first so I don't get it confused. So I'll call this malware string encode class. And for my B, I'll name this malware decode string, since it looks like it's also returning a string value as well, and taking in an encrypted string as input. And let's also name our other references in here so that we can, I think we'll want to paste this into VS Code and try and have it decrypt itself. So let's go ahead and start renaming these variables just to clear out some confusion so that it's easier to read all of these different method calls. So first, let's find all of the methods in here. Start with C. Looks like that didn't work. Why is it doing that? Here we go. Here's our C definition. That's very interesting. I don't know what it's doing, but JADX is having a moment. Don't worry, let's just rename this. Let's see, malware. And I see this shift 4 here. Looks like more byte array options on this string, so I'm going to call this malware shift string. There we go, now it updated. And we have, let's see, a call to a class right here. This looks like it's just taking in a string and base 64 decoding that string, so I'm going to call this malware base 64 decode. There we go. I guess that wasn't that A. See, when the malware authors name something the same letters, it gets really hairy to try and analyze all of this, which is why the first thing I like to do is go and rename all of my method names so that I can figure out which one is being called. So if you get confused, not to worry, I get confused all of the time with this, but luckily JADX is really nice about updating the proper method and class names, so just rename them and then eventually you'll figure it out. So I'll double click here. Doesn't look like this wants to update now that I'm renaming my variable names. There we go, now it found the class. Okay, this looks like more string manipulation. So I'm gonna name this malware string array manip for manipulate. And that's the constructor for the class right there. So we should be getting a better looking call now. There we go. So it renamed that entire fully qualified class name, which remember the fully qualified class name is the full name of the package plus the class name. And now this is looking a little bit clearer. Okay, last one that needs to be renamed is this one. There we go. This might be that variable. Can't tell. I don't know where JADX is taking me right now. Let me see if I highlight it. There we go. It's a byte array, okay. So name this. So it looks like it's just turning another manipulation of the byte array. So return B array. There we go. There we go. And I think I've renamed all of our methods in here. Go like that. Slower. Looks good. Okay, so now all of these have unique method and class names, so it's just a little bit clearer when you're trying to read this. And the goal here was to try and copy this code into VS Code so we can go ahead and start decoding some of these strings up here that look like they're all being called. I got hopeful seeing this base 64 decode, but it's also calling the decode string first, so we'll still need to decode this. Now, a big disclaimer here is technically you could manually decode all of these strings using, not that, CyberChef or something like that. But to me, I almost always prefer to just copy and paste the code in because I can clearly see this is not doing anything malicious, so I'm just going to run this and have it decrypt itself. And it's really easy just to copy and paste instead of having to try and mess with CyberChef to try and decode these. So I think that's good. Let's copy these in. So copy that. And I already have VS Code up and running, and I just made a simple hello world main function right here. So I have my decode class that I created, and I'm just going to start pasting these relevant methods inside. Make that a little smaller here. Okay, so I have all of my functions in VS Code that should be related to the string decoding. But it looks like we're getting a few errors, so let's just go through and decode and fix these errors that we're getting. And remember, the goal here is to try and decode these strings so that we can see what data this application is trying to hide and doesn't want us to know that it's accessing. So VS Code, and first error, simple error, it looks like the base 64 decode call is, if you go up to the top and check the imports, this is from Android Util base 64, and we're just using the regular Java framework, so this is not going to be correct, so we're going to do quick fix, and we'll just import it. And their definition in the Java framework is slightly different than the definition that's inside of the Android framework, so we can fix this. Let me just start typing in and see base64 dot get decoder, and you can just Google this if you're not sure, but I've done this a few times, so I just start typing it to help me remember. Then we can call decode, and it just takes one string as an argument. So let's paste this to here, remove the second argument, and that should fix it. Cool. Looks like we got rid of that error. Nice. And there we go. One more error for base 64, but we know how to fix that. And that's taking a substring, so let me just copy this code. Paste that here. And get rid of this second argument, since the Java framework version only takes one as an argument, that is the string that it's base 64 decoding. And I think this one was defined in another class if I remember, but I think that's our last error. Yes, looks good. So we might just need to add the other class as well. You go to the bottom. It was this method that wasn't defined. So let's double click to go to our definition. And yes, this class was defined. Not in the same one. So I'm just gonna copy this whole class and create a new file. And what was this class name? Oops. We'll just call it the same thing, since sometimes Java doesn't like it if you name it something else. That.java. And there we go, it defined our class for us. So we'll just copy this one more time. We can just select all and paste it in here. Save. Fix that error, so that looks good. Okay, so now we should be able to take any of these calls to all of these string decoding methods right here, and we should be able to decode any of these strings. Now, I can't remember which string was of interest that we were looking at originally, so let me go back. Okay, keep going back. Oh no, we don't want to do that. So where was our main class? It was this class. This dog, BH. Okay. And the call to our string class was right here. Okay, so we didn't actually have a specific value being passed in here. We were just looking at this class of interest. So just to quickly show you that this works, I'm going to try and decode one of these values. So I'm going to actually copy the whole function call and put that in my system out print line instead of hello world. Okay, what error are we getting? It wants it to be static. So public static, and we're getting one more error. Shift string, cannot make static references, same thing. Since I don't care if this code is pretty or not, I will just add the static keyword to make it work. And that should print our value to the console. ID bot. Okay, that's interesting. So because I already took a look at this, all I need to do if I want to is hit the semicolon character, and I can add a comment to this file. So this will show the string value above the decoded value. Now, I'm not gonna do this for every single value in here because I will be here all night, but I just wanted to show one example. And I can also name this malware ID. I'm gonna actually call this malware str for string ID bot. And there we go. So if we look above it, we have the string literal of it, and then I can also name my variable names to kind of match the decoded strings to make it a little easier in the code. So that was just proof that our decoder works. So let's keep going down. Malware. We'll call this string encode class, and remember lowercase because this is an object, not the class definition. And here we go. Looks like this is starting to get used, and we're creating a new string here. So this is getting the name of the class, so getting the simple name of the class, and then appending another value from our string encoder class. So let's take a look at what this value is. It was, looks like it took me to the wrong place. I think it was this IA. Yes, capital I, lowercase a. Here we go. So let's see what this value is. Paste this. Oops. I want to hit the run button. Ah, so this is just shifting, maybe? So I can do comment. My name is malware. Call this double shift characters. Don't really know what that's doing, but I guess we'll find out soon. So, interesting. So I'm going to rename this to malware class name. And I'll just leave that like that for now until I can figure out what this is doing. Might be appending probably another value to this as well. Let's continue on. And we finished analyzing our instance variables. So our variables right here. So let's move on to our onCreate method. So this is going to be called first as soon as this class is instantiated and this activity is started. So let's see what this is doing. I'm not too worried about this. I'm going to ignore that. It's probably just some check to make sure the app is working. Window manager, I don't care. We're declaring a new class A. And here are our interesting strings. And I have a feeling that we're going to be referencing these a lot to try and figure out the basic functionality of this application. So let me go capital O, figure out what that is. Here are we? Here we go. Paste this in. See what this is. Display width. Okay, so this is probably honestly really boring code right here. I might skip ahead to not waste my time. So I'll add that a comment, change the name, str display width. I don't know why they're trying to hide what they're doing with the display. Maybe interesting, maybe not. But let's see what this is doing. Okay, I'm gonna scooch up a little bit ahead and see what we have going on a little lower. Looks like we're starting a new service, so I'm probably going to skip and try and take a look at this service and see what it's doing. So the service is the code that's going to be running in the background, so the user isn't aware that it's actually running. It doesn't have any UI components. And then you pass the new intent object, so basically that's just letting you start the service. And you have to pass the class so it knows which service to start. So if I go on my left-hand side, I'll be able to find this class in my package definition, but I can just double click here and it'll open it up for me. Okay, so this is what's getting started. This is the constructor that's going to be called first. And since this is a service, let's see. On handle intent. So this is an intent service. So this is actually going to be called first. If this wasn't an intent service and this was just a regular service, it would be something like onStart would be the method we're looking for. Let's take a look at this. Okay. First, this is the string encoder class. I have a feeling this is going to be very interesting. So we have our instance variables, and then our constructor is going to be called, and then the onHandleIntent method is going to be called. Let me name our string encoder class. Let's call this string encoder class again. And this is yet again the package name. Let's call this class name. And okay, we're parsing an integer from here and storing it into this instance variable. What we're doing with it, I don't know. And then we're starting another service, or we're starting an activity. Interesting. So I'm not finding any malicious code yet. This code is nice and obfuscated and it's trying to keep me from finding the malicious components, but I will keep going for it and trying to find them. Let's see. Looks like it's just starting other code. So let me keep following the rabbit trail, and I'm going to bite this hook and see what this class is doing. Can we find anything interesting? Okay, it looks like we're getting some JADX errors. Okay, yes, so if you see this method not decompiled, this means that JADX actually failed decompiling this method, so you're not going to be able to see the nice pretty Java code. You're going to be stuck to looking at the Smalley code. And this occurs with a lot of different obfuscators. But for now, I'm just going to look at this Java code and see what we did successfully decompile. This is interesting. This looks like it's messing with the accessibility options and checking to see what accessibility versions we have and permissions we have available. Set service info. There we go. So this is really interesting to me, since malware commonly will abuse the accessibility services to try and get extra permissions and abilities to manipulate the device. So this is commonly used among banking trojans and many different other kinds of Android malware. So I think this is going to be the setup for the actual malicious behavior here to allow the malware author to actually perform their malicious behavior. Okay. Yep, this looks like it's related to a bunch of accessibility options. Interesting. Let me rename this class then. I'm going to name this malware accessibility. Should I rename this accessibility service manipulator? There we go. That's interesting. But now that's a little bit more interesting. It makes a little bit more sense. Looks like as soon as that service, that intent service is started, it's going to be trying to manipulate the accessibility settings. And start another service, or try catch, and then start an activity. So what's this? What's this service it's starting? So you see this extends service. So this is that onStart command that is going to be run first. Looks like it's making a new toast. So a toast is a little pop-up that pops up onto the screen that the user can see. And it's going to be adding the following text to this. Okay, so it's going to be We rename this malware toast service pop-up. Okay, so we have our accessibility. It's done first. Then it tries to pop up a toast. And then it's going to start a new activity. Okay. Aha. So here we see we're checking to see if this file exists. So I really want to see what file they're checking for. Because if you remember, at some point, we were looking at the Android manifest, and that had some classes defined on disk that were actually not reflected in our package explorer. So let me get an idea of what this is looking for. This is using our string encoder class again. Let me rename this. What's SD? Find that. SD equals, oops, here it is. Let's rename that. See what string this is. APK. Oh, well, that is interesting. Name, malware, string, APK. JB. Oops. Control F. JB equals. System.apk. Okay. I like that. This is getting more interesting. Malware system.apk. Name this string underscore. Oops, don't need two underscores. Okay, so it's looking for the directory apk and then a file called system.apk inside of that, and it's checking to see if this file exists. Then it looks like we're creating a new JSON object. This is getting really, really interesting. I really like this, and I want to see what JSON object it is creating here. This is also still related to our accessibility class. So I think this is still part of where it's trying to manipulate the accessibility settings so that it can perform some malicious behavior. So we still need to actually get to the malicious behavior. This is all still just the setup portion. So we have ascertained that this is going to be manipulating some of the accessibility settings. So I think I'll leave the remainder of this analysis to another video where we'll try and figure out exactly what this is doing to the accessibility settings, and we'll figure out what this JSON object is. So thanks so much for watching laurieWIRED, and I'll catch you in the next video where we'll try and look at those accessibility manipulations and try and see exactly what they're doing.